So let's take a look at the DevOps revolution. Let's talk about pipelines and repeated operations that can be systemized and optimized. And in some sense, this has come from the history of manufacturing. The Toyota production system that started after the Second World War and culminated with Toyota and the Japanese being very much ahead of the US corporations. And they'd done it by implementing what we now call the Toyota production system. And we'll talk about that, what they did, but it's basically very similar to DevOps in that they gave power down at the shop floor level to people that are actually on the production line. And they created an information system that allowed information to flow back up the pipeline. So if you imagine the pipeline is going from left to right, there's an information flow back up from right to left. And in their case, they implemented a pull technology in the sense that once you used a component in the car, that you would call for another component to be delivered. So that kind of pull system optimizes the amount of material in the pipeline and the speed of the pipeline as well. And later on, the theory of constraints and lean engineering were also applied to the pipelines. Lean engineering in particular was invented in MIT, and we'll take a look at the authors of lean engineering. And finally, we'll look at DevOps that has given rise to some companies being 400 times faster than others in speed from idea to deployment. So this is the pipeline, and it's very similar in most areas that you have some kind of version control, that you build something, you unit test it, you deploy it, you test that deployment and monitor it, and you'd like to measure and validate that it's successful. And all the way along, you give feedback for decision making. So this is the pipeline for software. But the Toyota production system started way back. So there were two brothers, and Sakichi Toyota saw his mother weaving and decided that he could automate this and build a machine that was powered by electricity, or back then it was probably by steam or some other means. And that was very successful. Then he saw the automobile in the USA and decided that they had to learn how to build them. So these are the two brothers. So that started just after the Second World War in 1948. And by 1975, they were far superior in their production of automobiles to the US. They implemented a just-in-time, so this is delivery of parts to the right place in the pipeline, just in time. They called it intelligent automation. We've heard the same phrase today. And they applied continuous improvement. And again, that's what we see today, that we'll deploy a minimum viable product and then continuously improve it. And today in the software pipeline, some companies are deploying 10 or 20 times a day. And finally, respect for people. Again, these pipelines only work if you have the right motivation of the employees and in some sense the right culture. And that's the difficult thing about digital transformation, is getting the right culture. Their operation, they focused the metrics on throughput, operational expense, and inventory. So these were the key performance indicators, the KPIs. In 1984, GM partnered with Toyota basically to learn the Toyota production system. These are some of the books that you should read just to understand the background. So The Goal by Goldratt, and Theory of Constraints, Machine That Changed the World by James Womack. And James Womack was also the author and the inventor of lean thinking, which was perfected for the aerospace industry. Theory of Constraints is fairly straightforward. If you have a number of processes and process A can only produce 5 units a week, process B 2 units per week, process C 3 units a week, where should you strive to increase throughput? In this case, it's quite obvious. Process A is producing 5 units, and they're going to pile up in front of process B because it can only process 2 units. So until we increase the productivity of process B, we can optimize and increase the productivity of C or A, and it won't make any difference as far as throughput and product getting to the customer. So the theory of constraints is you must focus on your constraint. So it addresses the bottlenecks in your pipelines. They also noted that batch size is important, and small batch size is better. So again, what we're seeing in software, instead of the big bang of trying to produce the perfect software first time, and typically that would take years, we're seeing minimal viable product being deployed and improved over time. So this allows feedback from the customer and continual improvement. So these are the 5 focusing steps of lean engineering. Identify the constraints, exploit the constraint, align and manage the systems around the constraint, elevate performance of the constraint, and repeat the process. So 20 years later, we're seeing similar metrics. So we borrow from lean manufacturing principles, limit work in progress. We try and make work visible, visual displays for key quality and productivity metrics and current state of work and defects. So making work visible is also important. We need to somehow have information about what's happening in the pipeline. We need to use data and application performance and infrastructure monitoring tools to make decisions on a daily basis, and use lightweight change approval processes. So what we're seeing with microservices is that the major services are coupled together by what we call microservices, and these have been optimized to be just single functions in many cases. For AWS, they'd be called Lambda functions. And that's a very different kind of architecture to the monolithic platforms that we saw being developed 20 years ago, i.e. the ERP systems, which are today hindering companies rather than helping them. So to make everything visible, we've got the Bayer Room principle, where teams gather at the beginning of the day just for 15 minutes, no need to sit down. It's just to see if all the teams, what they're doing that day, whether any of the work in progress is going to affect other teams. So this communication is very important, and to base our decisions on real information. So the 3 ways that Jez Humble and Gene Kim talk about, the initial way is that you have flow along the pipeline. Then the second way is you begin to have information flow back along the pipeline so that you can make modifications. And finally, the third way, and the ideal way, is that you have continual feedback along the pipeline where everyone is aware of the problems upstream and in fact downstream. So what they found with continuous improvement, continuous deployment, most problems are caused by complex, brittle deployment processes. And that's software not written with deployment in mind. And manual changes must be made to production environments and require multiple handoffs between teams. So deployment was always a harrowing process. So there are several books to look at, and Accelerate by Nicole Forsgren, Jez Humble and Gene Kim is one of the standard works. The DevOps Handbook by Gene Kim and Jez Humble as well, and Making Work Visible. This is particularly important, that to see the effects of what's happening along that pipeline. So the DevOps revolution started way back in 2008 when Patrick Dubois and Andrew Schaefer started Agile Systems Administration Group. Then in 2009, John Alspoor and Paul Hammond gave their famous talk, 10 deploys a day, Dev and Ops Cooperation at Flickr. They were trying to solve the problem of friction between the teams. So like running a 4-minute mile, once one company, namely Flickr, showed that they could deploy 10 times a day, other companies began to adopt this DevOps strategy. Now we've got some companies being 400 times as efficient as others, in speed from idea to product. So it's this friction between developers and operations teams, and what we're seeing in companies like Microsoft today is they don't have different titles, that the developers actually deploy the product as well. They test it, they call it eating your own dog food, test it and deploy it. And we'll see how in the cloud that's possible. So this is the famous Accelerate book. They looked at 2,000 companies and asked over 20,000 questions of those companies. And they found that compared to low performers, high performers have 46 times more code deployments per day. So more frequent code deployments, 400 times faster lead time from commit to deploy, 170 times faster mean time to recovery from a downtime. So we're going to have problems. We're going to get failures. The thing that we need to do is to change our organization so it can be agile and recover from those. There's 5 times lower failure rates as opposed to our previous way of doing things. So code is 1/5 as likely to fail. So that's amazing. We're down from months per deployment to hours per deployment. So Netflix business model, we'll discuss that in some detail because it's a great use case. But the teams are typically small. The technical teams are not that large. Here's some deployment stats. Amazon deploy something every 11.6 seconds. Mean time between deployments on a weekday, that's amazing. Maximum number of deployments in a single hour, 1,000. Number of hosts simultaneously receiving a deployment, 10,000. Maximum number of hosts simultaneously receiving a deployment, 30,000. These are amazing numbers. How do you go about this change? So this is by Scott Cook, Intuit founder. Installing a rampant innovation culture. They performed 165 experiments in the peak 3 months of tax season. The business result, conversion rate of website is up 50%. Employee result, everyone loves it because now their ideas can make it to market. And that's a fairly traditional company, Intuit, but even they've gone to the cloud. And similarly with SAP, they're now operating fully in the cloud. So there are 24 capabilities in 5 categories, and we'll go in and talk more deeply about these. But basically, they affect continuous delivery, architecture. So the architecture is different today. We have these loosely coupled pipelines instead of the monolithic platforms that we saw 10 or 20 years ago. So the focus is on product and process, lean management and monitoring. So management now needs to get out of the way and only touch things when it's needed. And a lot of this is cultural. A lot of the problems arise from having an old style culture and trying to do these modern day things. So we'll talk more about continuous delivery capabilities when we go into the DevOps itself, product and process focus and cultural capabilities. These are the things that we need to change. And measuring culture, these are Ron Westrom's categories, but certainly, as Netflix says, one of the metrics is that if you hear somebody wants to leave on your team, that you'll get really upset because you want to keep them. If they don't meet that metric, you probably shouldn't be keeping them. So have excellent people and give them the power to act. So who else is doing DevOps? Almost all the large companies. Even GE Capital, Nationwide, they're all trying. The Gap, Nordstrom, General Motors, lots of companies doing DevOps. We'd like to talk about technical debt because sometimes you do things because you have to get it out and you know you need to come back and fix it later. And this accumulates and has to be fixed. This is a great book on DevOps, The Phoenix Project. A great read. as I say, many of the principles come from manufacturing. We'll talk about cloud and containers because containerization has really helped. Now we can create a single image that'll operate on any operating system. So we need to talk about Docker, and we cover Docker and orchestration of containers in our later module. This is a typical AWS reference architecture, and this isn't just AWS. Any of the cloud providers have this kind of structure where they're providing services such as database, identity services, so large building blocks that then you couple together with these lightweight serverless functions. The cloud native interactive landscape is something that we'll talk about, but there are literally hundreds of products now. Often you don't realize that you need the product until you see what they're doing, but they can do things like optimizing your expenses in the cloud and understanding exactly where are your bottlenecks. So we'll come back and then talk about cloud native landscape. So these are some of the people operating, and understanding what each of these is doing is going to be a time-consuming effort. The main idea of DevOps is to get from idea to product faster. So to put your ideas into practice. The new computational tools, we're going to talk about JavaScript and some of the libraries. GitHub, for example, and NPM, the open source tools, give small teams tremendous leverage. So today, it's much easier to change the culture of a small team than to change that of a large corporation. So in fact, small companies have a tremendous advantage in this ecosystem. What should your team know? Well, we're going to give you all of these things in this course. So these are just some of the names that you'll become familiar with. Cloud container, orchestration, microservices, etc. So we'll go through an example of a cloud project that two of our students did in MIT, and hopefully you'll get a feel for how powerful the cloud is. So this is just an overview of DevOps and how it fits into the cloud ecosystem. Okay, bye for now.